support 1. It is given ABCD are the four angles taken in an order in a cyclic quadrilateral. So if we recollect about cyclic quadrilateral, what we have here within this quadrilateral, this is given. Now here it is A, B, C, D. Now A plus C equal to 5 and B plus D equal to 5. All of us know that in a cyclic quadrilateral what we have, the opposite angles are here and for some of the opposite angle is what? 180. Here some of the opposite angle will be what? 180. So that is what we have. Now if we take 5 support 1, the sum given tan A plus tan B plus tan C plus tan D. Now here children what we can do? Tan A and tan B we are keeping as it is and raised to can change. Tan C means what? C I can write pi minus A. So here we can write tan pi minus A plus tan D. Tan D what we can write children? It is pi minus B. It is pi minus B. Now children, if we see this one properly, it is 2 into pi by 2, 2 into pi by 2. Now 2 means even number, here also 2 means even number. So here what we get, it is tan A plus tan B plus, we'll put sign children definitely after discussion, so I keep some space. Again tan B, I'm putting some space because we'll put the sign. See children, is pi minus A. We are sure that it will be what? It will be negative. But we will understand what we have. Pi 2 into pi by 2. So this is 1 pi by 2, another pi by 2 minus something. So where this angle terminates? In a second quadrant. So in second quadrant tan is what? In second quadrant tan is negative. If in a second quadrant tan is negative, what will do? Ultimate output will be negative. If I add up, then what we get? We get 0. Cos 180 minus A plus cos 180 plus B plus cos 180 plus C minus sine 90 plus D is the expression given which you have to prove equal to 0. With this it is given A, B, C, D are the angles of a cyclic quadrilateral. Are the angles of a cyclic quadrilateral. Now this is the required to prove, and this is the given part. Now at first we'll start from the given information. That is what we have here. See, we have a circle here, and we have a quadrilateral here. This one. Now here A, B, C, D. We know in a cyclic quadrilateral, angle BAD plus angle A plus angle DCB equal to 180. There is the opposite angles here are supplementary. Okay, so here opposite angles are supplementary. Now, similarly, we can say another one, angle ABC plus angle ABC equal to 180. Same thing. Now, we'll be basically using this here. Now, angle BAB means angle A we are referring to, angle BCB we are referring to angle C, angle ABC they refer in the question as angle D, and angle ABC as angle B. Now, what is given here? We take the LHS part, the given expression, cos 180 minus plus cos 180 plus B plus cos 180 plus C minus sin 90 plus D. Now, our intention should be to convert the whole thing in respect to only two angles, because you can see angle A, angle C is related, angle B, angle D is related. So what we can do, suppose we are removing C and we are bringing A, that is we are expressing the C in terms of A. Similarly, we can do one thing, we can remove this angle B and express that in terms of D. So what we can write here, it is cos 180 minus C plus cos B. B, what we can write, it is 180 minus T. Next one, cos 180 plus C. Now C is what here? Angle C means, angle C is this one, that is 180 minus angle E. So you can write here 180 minus A minus sine 90 plus T. Now this one, cos 180 minus A, we write it once again, or we can write it as 2 into 90 minus A. Next, cos 4 into 90 minus T. Then what we can write, plus cos 4 into 90 minus C minus cos T. Why minus cos T? It's 1 into 90 plus the second quadrant, so this should be positive. Now here 2 into 90 minus A. 2 into 90 means cos will be remaining as cos only. Cos A, but the second quadrant, so minus. Why second quadrant? 2 into 90 minus A. So if you want, you can just draw smaller fourth quadrant and you can understand that this is 190, this is the second 90, minus something, returning back to the second quadrant, minus something, returning back to the second quadrant. That means this will be give us a negative output, because angle dimension is second quadrant, cos is upward, so this will give us some negative value. This one, 4 into 90. 4 means what? We know it is a complete cycle. It is a 4 means what we have a complete cycle starting from here ending up here. But since it is minus something, we'll be going back to fourth quadrant, and so what we can say, the angle this one times in the fourth quadrant. Now in the fourth quadrant, cos is what? Cos is positive. So this was negative, but this will be what? Positive. So we can write here plus cos A. Now I come to this term. The same concept, just in place of A, we have D now. So it will be positive minus cos D, and that gives us the result as 0. So very simple. What we have done, we have taken a cyclic quadrilateral, angle this plus angle this is 180, angle this plus angle this is 180. Those opposite angles of cyclic quadrilateral is supplementary. Now, always for this type of sum, our intention should be very clear that here we'll keep two angles and we'll remove two angles, because two angles, you can say A can be expressed in terms of C, or C can be expressed in terms of B, D can be expressed in terms of B, and B can be expressed in terms of D. So any two we can keep, other two we can remove, and then we can simplify. Sub part 3. It is given cos A plus cos B plus cos C plus cos D. Now here the given condition, here given condition is A plus C equal to 5. So here it is cos A plus cos B plus cos C plus cos D. Given condition is what? A plus C equal to 5, B plus D equal to 5, because angles of the cyclic quadrant. Now we'll replace here the values. Just will keep two angle same, and we'll replace the other. So it is 5 minus C plus cos 5 minus B. Now here it is 2 into pi by 2, 2 into pi by 2. Now 2 into pi by 2 means it will be cos will be remaining cos. It is in which quadrant? It is in the second quadrant. In second quadrant, cos is what? In second quadrant, cos is negative. Here, when the angle is in the second quadrant and you apply cos, then it comes what? It will give the negative output. So here also the same thing. So what we get? Cos A plus cos B minus cos A minus cos B, and that's it. And we'll just complete this. So the sum is over. Support tan A plus B plus tan C plus tan A plus B plus tan C plus D. Now, as we know that here, what is the given condition? Given condition A plus C equal to 5 and B plus D equal to 5. So simply replace this value. So here what is given? A plus B plus tan A plus B plus tan C plus D. So we can write here tan A plus B as it is. And here we replace the other angles. That is here 5 minus C plus 5 minus. Now here tan A plus B plus tan 2 pi minus A plus B. Now this is tan A plus B. This one we can write tan 4 pi by 2 minus A plus B. Now this gives us tan A plus B. Now this one, 4 into pi by 2, that means tan will be remaining as tan. Now this is which quadrant? That is very easy to understand. It is 4 pi by 2. This is 4 pi by 2. That means a complete circle here. That is a complete circle taking the anti-clockwise direction, reaching here and then coming back here. Why? Because it is minus something. So the angle terms in which quadrant? The terms in the fourth quadrant. Minus tan A plus B. And that is the focus. Support 1. Tan 1 degree. Tan 2 degree. Tan 3 degree. Tan 89 degree. Now, children, always when the angle is given, it is better to find the relation with the angles. If we observe here carefully, 1 plus 89, 90, 2 plus 88, 90, 3 plus 87, 90. So what? If we have 90, so see here, children. If we have two angles, theta plus alpha equal to 90, we can write theta equal to 90 minus alpha. Now, tan theta equal to tan of 90 minus alpha. And that gives us what? Quarter. and that gives us 1 by tan alpha. And this gives us tan theta into tan alpha equal to 1. So from here what we understand that tan theta into tan alpha will be equal to 1 if theta plus alpha to 90. Now this concept will apply here. Simple this concept will apply here. See. So this is what tan 1 into tan 89. Tan 2 into tan 88. Like this it will continue. Tan 44 into tan 46 into tan 45. So if we observe here, in all these parts, we have it 1, 1, 1. And this one is also 1. So ultimately, it is what? We just multiply 1, 1, 1, and on up to 1. So at the end also we get 1 only. So how many times we multiply 1? Ultimately, what will get 1? And the concept is this one. It is tan square pi by 16, tan square 2 pi by 16, tan square 3 pi by 16, tan square 4 pi by 16, tan square 5 pi by 16, tan square 6 pi by 16, tan square 7 pi by 16. Now, as I told you just in the previous sum also, that is always try to find the relation between the angle. So here also we'll do the same, and we observe pi by 16 in plus pi by 7 pi by 16 into what? It's pi by 2. Pi by 16 plus 7 pi by 16, pi by 2. Now 2 pi by 16 plus 6 pi by 16, pi by 2. 3 pi by 16 plus 5 pi by 16, pi by 2. And 4 pi by 2, 4 pi by 16, that will be what? Pi by 2. Here 4 pi by 16, that will be what? Pi by 2. So this is, we can keep separate, but here what we observe, pi by 16 plus 7 pi by 16, pi by 2. 2 pi by 16 plus 6 pi by 16, pi by 2. 3 pi by 16 plus 5 pi by 16, pi by 2. So here again we can show this one once, that theta plus alpha equal to pi by 2. Now this implies what? Alpha equal to pi by 2 minus 6. Now this gives us what? Tan alpha equal to tan pi by 2 minus theta. That is cot theta. And that is equal to what? 1 by tan. So this implies what? Tan theta into tan alpha equal to 1. Now, the same logic will apply here also. That is, we'll take the product as tan square pi by 16, tan square 7 pi by 16, tan square 2 pi by 16, tan square 6 pi by 16 into tan square 3 pi by 16 into tan square 5 pi by 16 into tan square 4 pi by 16. Now this is 1, this is 1, this is 1. Why? Why it will be 1? See, you can write here 1 into 1 into 1 into 1. Why this is 1? Is pi by 2. Or, and you can show after that why you have done this. As pi by 16 plus 7 pi by 16 is pi by 2. So you can take this first one as theta, second one as alpha. And you can definitely write this. Already have proved that. Now again, with this you can show, say this one also, 2 pi by 16 plus 6 pi by 16 equal to pi by 2. Again, 3 pi by 16 plus 5 pi by 16 equal to pi by 2. And 4 pi by 16 is what? Pi by 4. And what do we know? Tan pi by 4 equal to what? It is given tan 181 degree, tan 182 degree, tan 183 degree, and so on. And we gave tan 267 degree, tan 268 degree, tan 269 degree. And we have proved this is equal to 1. Now children, here if we observe these numbers properly, we can see a pattern. It is actually tan 180 plus 1. Next one, tan 180 180 plus 2 degree, and 180 plus 3 degree, so on. So ultimately what we get, tan 180 plus 89 degree. So this is what we get, that this 181, tan 180 plus 1, tan 180 plus 180 plus 2, tan 180 plus 3, multiplied up to tan 180 plus 89. Just we are multiplying these numbers. Now children, what is tan 180 plus theta? That we'll understand first. Tan 180 plus theta. Now that is what? Tan 2 into 90 plus theta. Now here what we get, 2 into 90 plus theta means here 190, 290 plus something. That is the angle dimension in which quadrant? Angle dimension in the third quadrant. And in third quadrant, tan is what? Tan is positive. So in this case, we can rewrite the statement as tan 1, tan 2, tan 3, and so on, tan 89. Now, here what we can say, again the same thing, 90 degree, alpha equal to 90 minus theta. Now tan alpha equal to tan 90 minus theta, and that is what cot theta, that is 1 by tan theta, and this gives us tan theta into tan alpha equal to 1. So you can rewrite this as tan 1 degree, tan 89 degree, tan 2 degree, tan 88 degree, tan 44 degree, tan 46 degree. So if it goes on this way, and we have another term obviously tan 45 degree. So which is also 1. So what we'll do is simply multiply each as 1. Now the whatever the number of terms you have here, here obviously you can find the number of terms, but here number of terms, whatever it is, ultimately it will be what? 1 only. Here in each of these cases, how many the pair we have made? Here we have 44, because you can starting from 1, 2, 3 up to 44 brackets. All this will give us 1. So 44, 1, 1, 1, 44 times 44 times if you multiply 1, it is 1 only. Again another 1. So 45 times you're multiplying, you'll get 1 only. It is given to prove that cos square pi by 4
plus sine square 3 pi by 4 plus sine square 5 pi by 4 plus sine square 7 pi by 4. Now, whenever the expression is given, this is equal to 2, which you have to prove. The proof part is this one. The question has told the proof that cos square pi by 4 plus sine square 3 pi by 4 plus sine square 5 pi by 4 plus sine square 7 pi by 4 equal to 2. So this is which we need to prove. Now, if we see the expressions properly, here if you see the expression properly, here if you add these two number, what you get? 8 pi by 4. I told at the beginning only, that is whenever the expression is given informing the angle, try to find the relation between the angle. If you add these two, what you get? 8 pi by 4, which is 2 pi. If I add these two, then also what we get? Pi by 4 plus 7 pi by 4, what will be that? If it is pi by 4 plus 7 pi by 4, what will get? It is 2 pi. That means basically this can be expressed, 7 pi by 4 can be expressed with respect to pi by 4. Here 3 pi by 4 can be also be expressed in terms of pi by 4. Pi by 4 can also be expressed in terms of pi by 4. Let's see various relations we can find out here. One is pi by 4 plus 7 pi by 4, that is 2 pi. 3 pi by 4 plus 5 pi by 4 will give us 2 pi. But if it is 2 pi, then we cannot change it to its complementary and get any proper result. So that may not help us. So there is another option is there, what we understand, or another relation which we can find, that all these angles are somehow related to pi by 4. This is pi minus pi by 4, this is pi plus pi by 4, this is 2 pi minus pi by 4. So all these angles are related to pi by 4. So you can start it in this way, that LHS cos square pi by 4, that is what we can write, 1 by root 2 whole square. Now sine square pi by 4, that is what? Sine square pi minus pi by 4. This is what we can write. Then next one, sine square pi plus pi by 4. Then sine square 2 pi minus pi by 4. This is what we can write. Now this one can be further written in this way, that is 2 into 2 by 2. This is 2 into 2 by 2. I mean, it's a pi by 2. Here also into 2 by 2. Now here 2 means what? Even number. Here 2 is what? Even number. Here 4 is what? Even number. So basically what we get here, it is 1 by 2 plus. Now sine square 2 pi into pi by 4. So it is an even number, that means you will definitely get sine. Here also you will definitely get sine. Here also you will definitely get sine. Now the question is about the sine. Which quadrant? This is in the second quadrant, this is in the third quadrant, this is in the fourth quadrant. But basically you don't need to see the sign here. Why? Because here power is what? Here power is 2. Power is 2, or power is, in this case also power is 2. So if you get positive or negative, ultimately square will make that positive only. That is what I mean to say. Here you definitely get sine square pi by 4. But here what you get? Here you actually get minus sine pi by 4 whole square. Because it is in the third quadrant angle. So here what we get? Sine square pi by 4. Next also sine square pi by 4. And then next one is also sine square pi by 4. So this is basically 1 by 2 plus 1 by root 2 whole square plus 1 by root 2 whole square plus 1 by root 2 whole square. So this is giving you half plus half plus half plus half. That is 4 into half, and that is 2. one very simple thing we'll understand. Suppose you have two numbers which are positive real number. A and B belongs to R plus. Then we can write root A minus root B whole square equal to what? A plus B minus twice root AB greater than equal to 0. So if we have A comma B belongs to R plus root A minus root B whole square equal to what? A plus B minus 2 root over of AB greater than equal to 0. And from this what we can write A plus B greater than equal to 2 root over of AB. And from this what we can write A plus B by 2 greater than equal to AB to the power of half. Now, whenever you have two positive number children, whenever we have two positive number A and B, we can write this A plus B by 2 greater than equal to AB to the power of half. Now this one is what? This is called AM, that you have done in class 10, arithmetic mean. And this is called geometric mean, which you don't know. So actually we do not need to know also. For time being, what you'll understand that A plus B by 2 is greater than equal to AB to the power of half. Therefore, because this will be taught in the sequence and series, so there we will say that what is the meaning of AM, what is the meaning of GM. Right now, just you'll understand this way, that if we have two positive real numbers, we can write A plus B by 2 greater than equal to AB to the power of half. A plus B by 2 greater than equal to AB to the power of half. And to keep in mind, you can think in this way for time being, that AM greater than equal to GM. Proof I have shown, but why these terms are AM, why these terms are GM, that will do in sequence series. So here, any positive real number if we have, we can write A plus B by 2 greater than equal to AB to the power of half. Always. Come to next question. Minimum value of 2 to the power of sin square theta plus 2 to the power of cos square theta. So you can think about an expression here, 2 to the power of sin square theta plus 2 to the power of cos square theta. Now children, here 2 to the power of sin square theta is always greater than 0. Why greater than 0? 2 to the power of cos square theta is also greater than 0. All of you have done exponential function. All of you have done exponential function y equal to a to the power of x. Here a is 2. So if you recollect that how the graph look like, in this case 2 to the power of x, so you can think it in this way. Why? We can think it in this way. This above x-axis for sure, because you see here sin square theta varies from what? Varies from 0 to 1. Cos square theta varies from what? 0 to 1. So if I draw here just approximately y to the power of y equal to 2 to the power of sin square theta. Y equal to 2 to the power of sin square theta. Now sin square theta will vary from what? Vary from 0 to 1. So when it is 0 to 1, when it is 0, we have this one. The graph will look like this. This is what we are likely to do. Something like this. Why? When sin is 0, then what you have? 2 to the power of 0, that will be 1. And as the values of x increases, I mean theta increases here, then automatically the value will increase. Okay, when sin is 0, you have that, and as the values increase, it will increase. But as you know, the upper limit is there. Sin square theta cannot be more than 1. So at most what you can get? At most you can get 0, 2, corresponding to theta equal to pi by 2. Just I have taken here theta equal to pi by 2. That is, in this case, since it is sine square theta, this is theta and this is theta prime. So see, from the beginning, we have 2 to the power of sine square theta plus 2 to the power of cos square theta. 2 to the power of sine square theta greater than 0, 2 to the power of cos square theta greater than 0, because both are exponential format. So exponential function, here you can see it is above the x-axis. If you do not draw the graph, no issues. You can directly write this one greater than 0. Why? Because the range of exponential function is what? Always positive. So this one greater than 0, this one also greater than 0. If both are greater than 0, then you can apply this am greater than equal to gm. We can apply am greater than equal to gm. So am greater than gm, what we get? 2 to the power of sine square theta plus 2 to the power of cos square theta whole by 2 greater than equal to under root of 2 to the power of sine square theta into 2 to the power of cos square theta. Now this will give us 2 to the power of sine square theta plus 2 to the power of cos square theta greater than equal to 2 into under root of 2 to the power of sine square theta plus cos square theta. Now this gives you what? 2 into root 2. That is 2 to the power of 3 by 2. So from this square, this what we can say, that is the minimum value of mean value of E is 2 root 2.